Hello, everyone, and welcome to today's webinar presentation, Distributed SQL, MariaDB Xpand versus CockroachDB, brought to you by MariaDB. I would like to introduce you to our presenters. We have Andrew C. Oliver, Senior Director, Product Marketing at MariaDB Corporation. Andrew C. Oliver is the Senior Director of Product Marketing for MariaDB. He is a prolific writer about technology, particularly open source and distributed database technologies. In the past, he has served on the board for the Open Source Initiative, founded Apache Poi, and was an early part of JBoss before its acquisition by Red Hat. Find him over on Twitter at ACOliver. Next, we have Rabi Mihai, Senior Vice President, Engineering at MariaDB Corporation. He brings over 30 years of core software development experience in building RDBMS products, as well as building and deploying SaaS applications. He served 10 years as the key engineer on the database engine at Sybase, later becoming the director of SQL Server. As engineering VP at Marketo and Market Live, Rabi implemented agile processes and practices, significantly improving concept to market deployment. More recently, he was the VP of engineering at Clustrix, acquired by MariaDB, bringing to market a highly scalable, commercial-grade distributed RDBMS product. He is now Senior Vice President of Engineering at MariaDB. Finally, we have Dmitry Volkov, architect at MariaDB Corporation. Dmitry is a performance engineer with an experimental physics background and experience in SQL, NoSQL database management and statistics. Overall, he has 20 plus years of experience with performance engineering. Before joining MariaDB, he worked for Oracle, IBM, and Salesforce. He is now leading the Xpand performance team at MariaDB. In his spare time, he loves to go long distance running. All right, now, without any further ado, we will kick it off to Andrew. Andrew, you can go ahead and take us through the presentation. Thank you.
All right, thanks everyone for attending. And I just want to remind you to please go ahead and enter any questions that you have in the dialog box, and we'll try to answer as many of them as we can at the end. So first off, if you're not familiar with MariaDB, we are the basis for the MariaDB community server, a database used throughout the world in many of the technologies that you use every day, such as anything from Wikipedia to WordPress to whatever. You'll find MariaDB technology in many of the things that you use every day. However, our portfolio expands beyond that. We have MariaDB SkySQL, which is our database as a service offering that allows you to host MariaDB Enterprise Server, which is based on our core open source technology, as well as Column Store and MariaDB Xpand, which we're going to be talking about today. We're all over the world. It's a company of many people from many different countries, and we have won numerous awards, Database of the Year, most recently Xpand won InfoWorld's Technology of the Year. And so MariaDB is a pretty important company in the database world. 75% of Fortune 500 companies use MariaDB, some of which are on this list, as well as smaller and more startup type companies, global companies all around the world. One of the key reasons that companies have chosen MariaDB and different organizations have chosen MariaDB is they're trying to get out of the license costs of legacy technologies, not just to save money, but in order to scale. If you're moving to the cloud, if you're trying to adopt to sort of this new era of real-time customer service and supply chain and real-time business, and with the kind of data volumes people are experiencing, they just can't afford to use legacy database technology. MariaDB is based on open source technology. We also have our distributed SQL offering, Xpand. Our offerings are available on multiple clouds, including your own cloud or in a hybrid cloud where you use some on-premise and then also some services in the public cloud. We have a low total cost of ownership, up to 90% savings. If you want a fully managed offering, we offer that. If you want to manage it yourself, that's available too, using all of our technologies. Xpand is our distributed SQL offering, which we're going to go into more today. There are some key reasons people are choosing Xpand. They want to reduce infrastructure costs and complexity. One of the great things about Xpand is that it's available both on-premise and in our database as a service, and it supports all of your application needs with one platform. If you're coming from a SQL database background, you know that SQL databases such as MariaDB have long evolved to handle both NoSQL data as well as relational data. MariaDB goes a bit further with that, with a NoSQL listener that's capable of speaking some of the protocol of MongoDB and other databases and technologies. It's able to integrate with Kafka. If you're trying to accelerate your cloud migration, eliminate legacy license costs, MariaDB Xpand is compatible with, first and foremost, the MySQL MariaDB dialect and wire transfer protocol, or in the wire protocol. However, it also has compatibility features that make it easier to work with existing Oracle code. It is a SQL database with a lot of commonality between PostgreSQL, SQL Server, etc. MariaDB goes beyond the idea of just self-service. So if you're using our SkySQL service, yes, you can do self-service. You can deploy a database on your favorite cloud, lots of instances, all of the kind of things that you would expect from a database as a service offering. However, we also offer SkyDBAs, which give you the which join basically as a virtual member of your team and give you the sort of database administrator capabilities that any organization is going to want when they're running a lot of complex databases at scale. So that would be things like helping you tune your queries or schema design, communicating with your team over real-time chat. So this is a service that goes above and beyond just sort of a support request. There's a lot of differentiators between our database as a service offering of Xpand and other databases. So one, multi-cloud, it's read-write scale. So if you compare Xpand or a distributed SQL offering to a more traditional offering, such as hosting MariaDB on RDS at AWS, that'll give you read scale, but not write scale. Xpand gives you both read and write scale. It is able to tolerate multiple node loss or multiple availability zone loss. We saw a lot of these sort of availability zone issues last year when a lot of companies had based most of their services out of the US East region, out of really one or two availability zones, and we saw those fail. Well, with SkySQL running Xpand, you'll find that we can survive multiple availability zones going down because of the architecture of our distributed SQL offering. In addition, we support mixed workloads because Xpand has columnar index capabilities and SkySQL has multiple different types of databases available, including an analytical database, a column store. You're able to run multiple different types of workloads through one general management console through the MariaDB SkySQL offering. In addition, we support mixed models, so you're able to do both relational and JSON NoSQL style data in one database. So let's talk about some of the modern challenges that distributed SQL addresses. First off is scalability. That includes both performance and throughput, so latency and throughput. The next thing is elasticity, which is great. On your busiest day, you might need 10 nodes. On your worst day, you might only need 3 or 4 nodes. Do you want to pay for your busiest day on your worst day, and do you want the performance of 4 nodes on your busiest day? You want to be able to grow and shrink that deployment as you need. And that's one of the powers of distributed SQL. We're able to use more nodes as you need more nodes and shrink when you don't, in order to save you the cost of the cost of running all of that. So thinking about that, that blue line there is sort of your predicted workload. If your actual workload is much bigger than what you predicted, and hey, we're anticipating some growth, but in the real world, your utilization on the internet or on the cloud or whatever tends to be a lot more spiky. You end up with things where, oh, suddenly I'm doing twice as much as I'd predicted, and then the next day you might be doing half as much as you predicted. It balances out to the blue line, but your performance is terrible when you're wrong on one way, and your cost is too high when you're wrong the other way. So being able to contract and expand your provisioning allows you to avoid over and under provisioning. It allows you to get the best performance and throughput when you need it, and it allows you to reduce your costs when you don't. If you take a traditional relational database and we talk about scale, in general, if you've got two primaries, two read-write nodes, you're really going for availability. If you're going for multiple replicas as read-only nodes, you get read scalability. But also when you do this, you're limiting the database size essentially to your node size. So if a single node can't handle more than X number of writes, then you're limited to that. And if a single node can't handle more than Y number of reads, then you're limited to that. When you add more nodes, you don't get twice as, 1 + 1 does not equal 2, it equals 1.8. These numbers are made up, but the point being you get diminishing returns as you add more nodes. The great thing about traditional relational databases is because we're not really distributing any of the writes or what have you, we're just replicating them all at once. We're not doing any work to distribute the workload. They can be extremely low latency up into the point you reach their capacity. So that is an advantage over a distributed database. If you look at the capabilities of something like Xpand, we're able to chop off 2 nodes and still 2 availability zones essentially, and still survive. There's still data, sufficient data on one of the other nodes. For distributed SQL, queries are executed on any node. Writes are executed on more than one node. If you look there in that first box, it says table 1, P1, which stands for partition. We actually call them slices when we are talking about MariaDB Xpand, and then replica 1. Now, this is not the same thing as a replica a la traditional database. What we do is we take your table and we slice it into multiple different partitions, and then we make sure that each of those is replicated on at least one node. You can change this and it can be replicated on more nodes. But you see there that that first table has that first partition. There's a second replica of it on node 2. So if we lose node 1, node 2 still has that data. We could replicate it on more nodes, say 3 nodes, 4 nodes, etc. But if we've got it at least on one node, we have no data loss just from losing a node. If we want to survive multiple availability zone failures, say, we might have a replication factor or replica factor of 3. Writes are executed on more than one node. It's linear scalability. If we need more capacity, we add more nodes. The tables can be sliced and diced and distributed to more nodes. Transaction coordination is required. So when we do a write to a node, it has to be coordinated in order to provide ACID compliance consistent data by coordinating that write with the other nodes that it's written to. It is higher latency than, say, straight MariaDB Enterprise Server, because MariaDB Enterprise Server doesn't do all this work to make sure that things are more available and more replicated and more distributed. So scalability is in general a hard problem to solve. If you try and solve it with hardware, you scale up to a certain point and you also can't scale back. It's not elastic. So you just buy as big of a machine with as many drives and as many controllers and CPUs and whatever as you can, and then that's what you have. You've got enough for that day that you expanded to. Sharding in the traditional manner, we can call what distributed SQL databases do auto sharding, but sharding in the traditional sense, where we go and divide up a table based on customer A through F or on node 1 and so on and so forth, is complex. It's a little brittle. It's difficult to maintain because you suddenly find that certain nodes get used more than other nodes. There's a high engineering cost. Those queries get complicated. You have transactional issues with dividing data that way. There's query restrictions, what you can and can't do, because you've got to join data between these two different nodes together. It's a complex way to try and get more scale. If we go with something like NoSQL, you end up with more primitive querying. You can certainly find a way to use, say, the MongoDB aggregation framework or whatever. But if you've ever tried to do something as simple as what you're able to do in like 2 lines of SQL, a lot of times you find it's rather primitive. It doesn't quite do what you want. The performance isn't always what you're looking for. Data modeling can be complex because you've got to stick everything in one document, or you deal with the fact that joins aren't so efficient in a lot of these NoSQL databases. Many of these added ACID compliance to some degree, but it's usually a client-side trick. It's not the full sort of transactional consistency that you come to expect if you've been using a relational database. So these were not originally sort of your systems of record. They've been trying to get there, but really these were designed for scale and not to be systems of record. And you'll see that the warning label in the documentation on using transactions is usually pretty long. They require a lot of times specialized tools and administrative stuff. So a lot of times if you look at your army of analysts and the different people, they all know SQL. Even if they don't know how to code, they don't know anything else, they know SQL and Excel and some of those sorts of tools. So this is where SQL databases have kind of continued to prevail. So how do we solve these problems for SQL databases? First, a shared nothing architecture. Secondly, we build in scalability and elasticity, the ability to add and remove nodes on demand. We use tools like Kubernetes and what have you to make them self-healing. We also add the ability for these databases to self-manage. So if they see that, gee, node 2 is much more busy than the other nodes, then Xpand's able to say, oh, I see a hotspot. I'm going to slice this table up a little bit more and distribute that elsewhere. Or it may just say, I need to move this to a different node because these two different slices are getting, these two different partitions, these two different slices are getting used more than other things. Continuous availability. So if we're looking at modern cloud, modern business, we're expecting the business to be up 24/7 all the time. So something goes wrong, it should automatically fail over. Now that trick is not just the database architecture. There's other things around the database that make that work. In the case of MariaDB, it's a proxy server called MaxScale, which is able to replay transactions, failover sessions, all of that kind of functionality to make it so the client doesn't know. You don't have to code for this. You don't need to catch all of the different exceptions or what have you that might be involved. You just code to a single IP. It's standard SQL, including joins. It has ACID transactions with the same kind of expectations you have of a normal relational database. So when should you use a distributed SQL database? One, if you're looking at locking issues because you've got different sort of an older database that uses pages and this and that, and you want to be able to query more efficiently. You have online schema changes. You need faster backup times because backups themselves are something that benefit from distribution of that workload. Your cost of operations are too high because you're having to buy huge nodes to handle your database, because if you just replicate the entire database, then every node is serving that entire database versus being able to slice it and dice it and serve parts of it from all of the different nodes. You need higher availability and potentially better disaster recovery. You've exceeded the capacity of a traditional relational database in terms of concurrent users. You've exceeded the capacity of your database in terms of queries per second, transactions per second. Your storage needs exceed the capacity of your traditional database. Because again, I can use lots more nodes horizontally scaled and serve a larger database. Next, you've found the limits of your NoSQL clustering technology. If you look at a lot of these NoSQL databases, the way that they were set up as far as their clustering technology, it's a much older sort of design. It's not this completely horizontal. There's some nodes in between you and the nodes that you're trying to hit that handle that clustering topology. You need to be more where with Xpand you can write or read from any node and it'll get to the node that it needs to get to. You need to be more cloud-friendly architecture. You want to consolidate multiple databases. You're trying to get off of some of your legacy database clustering technology. But let's talk about when you don't necessarily want to consider a distributed SQL database. And I'll remind you, this is one of the technologies that MariaDB offers. We do offer an analytical database, column store, and we also offer the client server traditional MariaDB enterprise server, which is based on MariaDB community server. It's a hardened version, and this gives you some of an alternative. So if you have data that you want to manage as a service in the cloud, but it doesn't need all of the features of a distributed SQL database, you do have that option. So if your database fits cleanly on one node, you find that your traditional relational database provides sufficient throughput. You've got low writes and simply need to scale reads, or you need low latency in the sense that, let's say you've got some old Hibernate code that, if you're a Java developer, that queries the order table, for instance, and then loads each order line item one by one, and there's thousands and thousands. Maybe that wasn't the most efficient way to do it, but you're not trying to reconfigure, rewrite that code. It's expecting the semantics of a non-distributed database. You may find that that you're better off with something like MariaDB Enterprise Server. So we're going to be talking about another distributed SQL database, CockroachDB. It is based on Google Spanner, the Google Spanner white paper. The founders, I believe, worked on Google Spanner and then left to start this company. It is based on the Raft algorithm. So we are based, Xpand's based on Paxos. Unless you're a real distributed computing nerd, maybe you don't care too much about this, but they end up being the reason this technology is available now is that we came up with the algorithms to be able to coordinate transactions and be able to coordinate group membership across a relational database, across a cluster. CockroachDB is PostgreSQL compatible, or at least partially PostgreSQL compatible. It does differ in some ways. They recently launched their serverless beta. It's on the lower end, it's free for 5 gigabytes. It's super easy to get started, and they've done a really impressive marketing job. I'm very impressed with their marketing team. MariaDB Xpand is a distributed SQL offering. It is based on Clustrix, which was acquired by MariaDB. It's part of MariaDB Enterprise, so you can run it on premise, or it's also part of SkySQL, so you can run it in the cloud. It's Paxos based. It is MariaDB and MySQL compatible. In addition, and this is a feature that I don't believe is available in any other distributed SQL database at the moment, it offers columnar indexes. Now, why is that important? Because you may want to do some ad hoc queries, do some real-time operational analytics or personal analytics. How many orders did this customer have in the last month? What were my orders? So if you think of, say, the Amazon order history screen, and you're trying to find that thing that you bought last year at the same time, you might go and do some queries that pull back a lot more rows than a traditional transactional database is used to. So it allows you to do sort of pseudo analytical or lightweight analytical queries on your actual transactional data on your actual operational database. It offers supported self-service, so we offer this both in our on-premise, in a hybrid format, and in the cloud. And you can get SkyDBA support in order to help you use this. So if you're using a bunch of newfangled databases and what have you, your DBAs may not be as experienced with a distributed SQL offering as they are with, say, traditional MariaDB. So this is a really good service to be able to use when you go to production. So without further ado, I'm going to turn it over to Robbie, who's going to talk to you about the benchmark and how we went about setting up this benchmark against CockroachDB, and give you some ideas about how you can do this on your own. Robbie.
Thank you, Andrew. I'm going to describe in general how we approach these type of benchmarks, what tools we're using. So first and foremost, our tool of choice is Sysbench. It's an open source technology that's been very popular, and it's compatible. It can generate SQL for MariaDB, MySQL, and Postgres. So we have an option to compare different products this way. We use it a lot for automation because you can specify all sorts of parameters on the command line, such as table and data sizes, number of tables, how many sessions you want to run concurrently, the type of mix of queries you want to run. So it's a very rich tool that allows us to generate these type of workloads. And then it returns a lot of useful information about the benchmarks you have run. In particular, we're looking at the overall and the 95th percentile data, but it obviously supports a lot richer data output at the conclusion of these benchmarks. So why using Sysbench, and in this case we're using the 9010 workload. And so as I mentioned, Sysbench is very popular. Many of our customers use it to test various workloads against whether it's Xpand or MariaDB Enterprise Server. It's very easy to set up and run. Now, the 9010 workload is basically it's a mix of reads and writes, where 9 out of 10 transactions are reads and there's one update. And so the reason why we use that is a fairly simple to understand benchmark. We're not doing anything esoteric. And at the end of the day, every application in their life cycle will do point selects, you look up an account, you look up an inventory, they will also do point updates as well, right? You update your password or your email or update inventory. So these are very typical sort of run-of-the-mill operations, and it's a very nice way to measure kind of the low-level operations and the efficiency of these operations. So we chose that. Now, our methodology for running benchmarks is, if you go to the next slide, it is to give you an idea of the total system capacity. Instead of just publishing one number, bragging rights for the highest number or the lowest latency, we want to give you the full picture of how your system behaves under various loads. And so the way we do this is that we start at a concurrency level of number of sessions, and then we keep increasing that concurrency. And at the same time, we capture along these runs various points, especially with throughput and latency or response time, and we plot them in a single chart. And so what this gives you a total picture of how your system behaves under various workloads. So if we go to the next slide, this kind of a benchmark generates a chart like this. This is an example. So Dimitri will show you the actual runs that we obtained with Cockroach and Xpand. But this is an example of these runs where we started at 8 concurrent sessions and we keep doubling it all the way up to 1024. And in this particular case, for this chart, in this configuration, we can conclude a couple of, or we can make some observations. First of all, we can see that as we increase the level of concurrency, the latency is also increasing. Throughput is also increasing, but the latency is also increasing. And that's normal behavior because you create contention on various system resources. And so systems take care of that by creating wait queues and locking mechanisms. And so that will increase some of the wait time. Now, we also can observe that above 256, we basically hit this knee curve. And the sneak curve is, again, also a correct behavior, and basically shows you that you ran out of system capacity. You can still push more transactions with more concurrency, but now your wait time is increasing really rapidly. And so the useful the useful capacity of the system is somewhere between 128 and 256 concurrent sessions. And that's where you still have room for spikes, but anything higher than that, if you really need lower latency at higher concurrency, it also tells you that you probably need to either switch to a bigger system in case of these single server applications, or with a technology such as Xpand or Cockroach, you can keep just adding additional nodes, and the system will rebalance across multiple systems and will give you more capacity, so your latency will start coming lower at higher concurrency levels. And so that's kind of in general how we do benchmarks, and we characterize these across many different points. Obviously, we run many different benchmarks, not just 90/10, and the concurrency level can increase even higher to see, on a large scale, how your overall system behaves. With that, I'm going to hand it over to Dimitri to go into the details of the benchmark with Cockroach.
Thank you very much, Robbie. Good morning. Good evening, everyone. My name is Dmitry Volkov, and I walk you through our actual results. But before talking about results, it's super important to talk about benchmark setup. If you've ever been doing some benchmarks, you know that setting up database is a task on its own, especially if you're trying to set up somebody else's database. So to avoid those problems with setting database and dealing with parameters, we decided to test a cloud offering for both Cockroach and MariaDB. So bear in mind, we just spin up instances in both clouds and start testing those instances. This process, by the way, super easy. You will get, for both companies, it takes about half an hour, and you get ready to work database with optimal parameters, at least what the companies believe are optimal parameters. So to make this cloud offering as close as possible, we use the same region in Amazon Cloud, AWS. We use the same 3 instances with 16 virtual CPUs, same amount of memory. We over provision IO just to make sure we're on the safe side that IO is not a bottleneck. And we use 3 nodes for Cockroach because what we found, if you use more nodes, then unfortunately Cockroach start distributing nodes between 4 zones, which obviously impact performance. So 3 nodes, 3 zones. Also, we have to reconfigure Xpand, as Xpand by default use 2 replicas, and Cockroach use 3 replicas. So again, to have apple-to-apple comparison, we reconfigured Xpand for 3 replicas. And lastly, we use very huge driver. Again, just to make sure the driver is not a bottleneck on our benchmark. And one of the latest is bench available out there. So next slide, please. So first, we run a workload called point select. Point select is very, very light workload doing index reads. Data size was fully sit in memory. So it just think about almost like a smoke test. We would like to know how both database perform is the most optimal conditions for those databases. So before run this workload, I obviously read about the best practices for Cockroach database, and Cockroach says if you would like to run this bench, please switch secondary index off and don't use after increment. And Xpand also recommend do not use after increment. So those best practices were implemented, and you see the full sysbench command down below this graph. So this graph is what Robbie was just telling you. Its y-axis is P95 latency and x-axis is throughput. To our surprise, you can see orange line that with 128 threads, it's make a very sharp turn almost back. So it's become obvious that we somehow overload Cockroach, but just to remind you, it's equal number of nodes, equal number of CPU. Everything from hardware was the same as close as we were able to do. So Xpand was able to run until 1024 threads without any problems. Andrew, can you click on the slide? Yeah, so let's look on the low end of this workload. But with low number of threads, actually, we were super surprised, positively surprised how Cockroach running when number of threads is low. It essentially provides even better, slightly better latency than Xpand. So it tells us that actually database was configured right, everything was right. Just something happened with this 128 threads of sysbench. Okay, it was point select, so let's check 9010 workload. The next slide, please. So 9010 workload is almost ideal OLTP. Same. Each transaction includes 10 statements. So 9 was selects and 1 was update. All right. Same best practices were applied for both Xpand and Cockroach. And again, you see pretty much the same behavior. Obviously, throughput is different because different workload, but overall behavior is the same. 128 threads, and you see this curve going straight to the sky. Okay, let's also verify low end with lower number of threads. Yeah, pretty much the same picture. So Cockroach behaves run very fast, impressive, it's very impressive database with low number of threads. So what could be a reason for that? So next slide, please. So our impression was that Cockroach just become CPU bound, and on the right top of this slide, I put a CPU percentage. Yes, Cockroach nodes were loaded around 70, 80, 85, 90 percentage of the load. So definitely we overload the nodes on a Cockroach. This slightly, it's actually light workload. So we were surprised, and then we went to documentation, and it says actually Cockroach Lab perform better when connections, the number of cores multiplied by 4. And even many workloads perform better with maximum number of active connection between 2 and 4. So it's become obvious that it's super easy to overload Cockroach database, unfortunately, and then it's pretty much become unstable, latency just go to the roof. The problem is how you can manage exact number of threads database like, right? So it's very hard to do in practice. That's why we believe Xpand is much more suitable for real life workload when you pretty much don't know how many threads you can get. So database should capable to do it. And next slide, please. So we try to improve Cockroach performance. We implement some settings recommended by Cockroach, but we haven't seen any much improvement out of that. So we put those settings because we think it's may be helpful for you if you're running Cockroach performance tests. But again, our experience, it didn't impact results much. So next slide, please. So why we think Xpand did better? So first of all, Xpand is written in C and highly optimized for resource usage. And you can see graphs are kind of obvious when you put database on a stress, at least in given number of CPU and nodes, it become very clear that Xpand has handled this workload much better. So Xpand had multiple client threads, very efficient with minimal overhead. So we have noticed such limitations. Obviously, as you know, when you put more threads, latency goes up, but it's nowhere close what we seen with the Cockroach. And so my team worked very closely with SkySQL development team to actually deliver this cloud offering and make sure that performance in the cloud is the best in industry. Because one thing is just to have a good database, and completely different thing is have a good cloud offering. So again, I would like to remind you that we tested not only databases, but we also tested cloud offers. Next slide, please. Thank you, Andrew. Back to you.
All right, thanks again, Dimitri. So Xpand is available in MariaDB SkySQL, which is really kind of our database as a service offering for MariaDB Enterprise Xpand and our analytical database column store. And first off, I'd like to thank everyone for attending. Please go ahead and enter any additional questions that you have into the dialog box. We'll try to answer as many of them as we're able to. So if you want to go ahead and do that now while we wrap up, I would appreciate it so we can get to as many of them as we can. I'd encourage all of you to check out the MariaDB Developer Hub. So go to mariadb.com/developer. You'll find code samples, tutorials, blog posts, webinars, videos, documentation, all of that on the Developer Hub. And we've got a GitHub repository as well with some of those examples. So in addition, if you want to join the MariaDB community Slack, we have a benchmark channel there, so we can talk to you. Dimitri is on there to talk to people about benchmarking MariaDB Xpand and our other offerings and how to go about it. And happy to talk you through some of the stuff that we did. And it's a good place to ask other MariaDB and Xpand questions. So please go ahead and add any questions. This is my Twitter handle. If you want to hit me there, that's also my email address. But we'll answer as many of your questions as we can right now. First question, is there a free or community version of Xpand? You can try Xpand for free on, there's not presently really a free as in MariaDB community server, but you can try Xpand for free on SkySQL. We'll give you a $500 credit if you go to mariadb.com/skyview, all one word, SKYVIEW. Then you can get a $500 credit and go ahead and try Xpand right now if you like. The next question is, are there any notes comparing SkySQL to CitusDB? So we haven't done any kind of performance benchmarking against CitusDB. However, if you look at the overall architecture of CitusDB, which is built as a series of extensions to Postgres, there's a lot of, it's a little bit more, it's almost a little bit more comparable to more of a database clustering offering than a full distributed database. There's limitations as far as where writes are going, how to distribute writes. It's sort of a hybrid between sort of the Hadoop file system / PostgreSQL extensions / Postgres, and the way that it's transforming queries in order to slice them up means that there's some transformation stuff going on there. So it is more like a traditional sharding offering than a distributed SQL database. I would anticipate that for many workloads, Cockroach would probably outperform it, let alone Xpand. However, we have not tested it. I'm just giving a supposition just based on the architecture diagrams and the information in the documentation. They're talking about doing inserts at 50,000 per second. We have production instances of Xpand doing far more than that. So I would suspect that the throughput and performance and what have you would be better on distributed SQL offerings than it is on Citus, just based on their architecture. But with that said, we have not benchmarked it, so keep that. So that's with a grain of salt. The next question is the load balancer a single point of failure? So MariaDB has the max scale proxy, and max scale is available in a multi-node HA setup. So you can have one distributed, and then secondly HA, so that when one of the proxies fail, you fail over to the other proxy. So it does not have to be a single point of failure. The next question is how high a latency price is to be paid when considering distributed SQL? And I'm going to go ahead and turn that one over to Robbie.
Yeah, so it really depends on the workload. So we have seen that point selects and updates get around the 1 to 2 millisecond overhead. But you know, other type of queries that maybe are more complex, then the overhead is really negligible. So we measured various types of workloads, and that's kind of where we hone into it. That's 1 to 2 millisecond overhead.
Thanks, Robbie. So we have a couple other questions that have come in. Please keep them coming. And the next question is, you've said that there's an overhead of using a scale-out database versus a single system such as MariaDB Enterprise. Have you quantified that overhead? And I'm going to turn that over to Dimitri.
Sure. So with distributed database, obviously, all nodes of distributed database need to talk to each other. So I would say if our cloud is relatively complex, distributed database has its own benefits because all nodes can work in parallel. Obviously, if workload is I/O demanding, that multiple nodes can do I/O faster. If your workload is really simple and fit into memory, then single database, when it's can be processed inside one operating system, inside one physical virtual machine, is faster. So in SkySQL, if you distribute between nodes, definitely every query add a millisecond or two to process, because data may be sit in different nodes. Your driver may come one node and data sit in another node. So have this in mind. But what you get what you get for that performance penalty, you get really distributed database, and then you don't worry about losing one node or even one zone. Back to you, Andrew.
All right, so the next question is, how much does it cost to run, for example, a 3-node expand on SkySQL? To turn that one over to Robbie.
Yeah, I mean, depending on the cloud, of course, and the instance size and a whole host of other parameters that you choose, I mean, you can run a 3-node cluster as low as $1.85 per hour. As Andrew already mentioned, we have a voucher that allows you to try this free for yourself. But as you select different parameters and as you configure your system, there's a real-time calculator that will show you how much is the total cost, whether you paid by hour, by month. And so you always know how much you're going to be spending as you select different configuration and instance types, and you set up your system. So there's no hidden cost or surprise. You will always know what you're paying for.
Thanks, Robbie. So the next question is, are there any special nodes in the Xpand cluster? And so the answer is no. All the nodes are equal. You can connect to any node and you'll have a consistent view of the database. That's why load balancing works, because there are no special nodes. Each node can accept connections, coordinate transactions, and write data to disk in parallel. And this is, different from some of the other database distributed database offerings that have a more traditional style, less shared nothing scale out architecture. All right, we have another question. You mentioned columnar indexes and Xpand. Can you tell me more about that? I'm going to turn that over to Robbie.
Yeah, sure. So the columnar index is a new form of index where we store data in a column-oriented storage, and we also use compression on that. And so you can pack a lot of information within that for if you're interested in a specific column. If you think about it, every time you look for a column on a row-oriented system, you bring back the entire row and then you create a projection on that column that you're interested in. So there's a lot of wasted sort of resources coming back if you're interested in one or two columns. So the column index is solving that, because you can pack a lot of information in a lot of tight space, so the scan will be very fast. Now, what's really nice about our implementation is that you can mix column index with regular row indexes, and our planner and optimizer will choose the ones that gives you the fastest answer. Basically, it's a cost-based optimizer, and these indices have a cost associated with them, and so the lowest cost will be selected. Really, if you just boil it down, what the columnar index brings you, it really optimizes certain type of queries where large data sets are involved. So you would have to scan many, like millions of rows. In this case, columnar index is very fast. We have seen like aggregations anywhere from 3 times faster to up to 50 times faster. Again, depends on the data type, the compression in the query. So it's a very fast way to get some sort of analytics, operational analytics on your OLTP data. It also simplifies your tuning work, because if you have a high dimensional table or schema, in general, you would have to create various permutation of regular indices on it to have covering indexes for various combination of columns. In this case, you just create column indexes on the columns that you're interested in. And again, the optimizer would choose the right strategy to return your results at the most optimal way. And then finally, the third part of this is that you can run your OLAP workloads on OLTP data without needing to do any kind of extraction. So you don't need to do ETL. You can run directly on your OLTP data and with minimum disruption of the OLTP workload. So it's a very powerful feature that allows you to mix, again, lightweight analytics with OLTP.
Outstanding. Thanks, Robbie. We have another question. So the question is, technically I understand SkySQL is a combination of MaxScale and MariaDB in the background. So 3 nodes, as you discuss, actually means 3 Maria, and I think they mean MariaDB Xpand nodes and 1 or 2 MaxScales. So I think the basis for this is how many nodes total when you include the MaxScale nodes. And I'm going to throw that one to Robbie again.
Yeah, I mean, so when you run a benchmark, so let's say you have 3 nodes in the backend, so then MaxScale is going to take a 4th node, and depending on the workload, you know, I have to configure it to make sure that it doesn't become a bottleneck. But again, that's all included in the total cost of the configuration. So you will see how much it costs to run the 3 nodes plus the MaxScale node.
All right, thank you, Robbie. Another question, if I had a MySQL app, can we realistically point the connection to Sky and assume it'll work? And I'm going to throw that one to Robbie again. I would note, by the way, that we have both MariaDB Enterprise Server as well as Xpand. So if we're talking about an existing MySQL app that doesn't need the full features of Xpand, it might make sense to deploy that on straight MariaDB Enterprise. So Robbie, if I had a MySQL app, can we realistically point the connection to Sky and assume it'll work?
Yeah, pretty much. Our typical migration strategy involves, let's say, setting up your original application from MySQL to Sky with replication. And so, because what you want to do is replicate the schema and the data, and Xpand is compatible with both MariaDB and Xpand replication, so you can replicate from MariaDB or MySQL to Xpand or vice versa, so they're compatible. And so our typical migration strategy is to start with that, and when the data is sort of complete on Xpand, then you switch over your application to Xpand, and it should work.
All right, thanks, Robbie. So we're gonna take one more question, and then we're out of time. I'm gonna throw this one to Dimitri. Can you explain P95 latency versus average latency and why P95 is used? And you've got 1 minute.
Oh, yes. Thank you very much for that question. So P95, we use P95 because it's almost the most worst case scenario. And it's much, much close to real customer experience out of database versus average latency. That's why we always provide with our results P95, because that's what you actually will be dealing with customer complaints out of your application. So it's much more useful metrics during the test. And also average database can be okay, misleading. That's why, again, looking for P90, P95, I highly encourage everyone out there pay attention to those metrics for any database related tests.
All right, thanks, Dimitri, and thank you everyone for attending. Remember, you can check out, you can hit me up on Twitter at @ACOliver or shoot me an email, and I'll be happy to answer your questions. You can also join us on the MariaDB community Slack, and we'll happily answer questions there. Thanks again for attending, and we look forward to seeing you around on on SkySQL and Xpand and the MariaDB community platform.
And with that, DZone would like to thank Andrew, Dimitri, and Robbie for an outstanding presentation. DZone would also like to thank MariaDB, providing the audience with a great webinar. Lastly, thank you to everyone who attended today, and we hope you learned something new that will help you in your developer career.